Hey, chemistry. If you missed our class meeting today, I want to give you a summary of what we went over. You can also find this PowerPoint in the files section for the class. First of all, an announcement. Because this class is on an accelerated schedule, the end of our semester is in 2 weeks. What is normally a term grade that you can fix after the fact by turning in late work is not a term grade. This is the same as a semester grade and it will be going on your transcript. So if you have anything that is late, please get that turned in before November 6th, I think is when I was told I have to have grades in, but get your late stuff turned in. If you need help, come to office hours. You can turn in assignments at any point without any late penalties for this class. So the first thing we talked about was writing ionic formulas, and I covered another way to do it that's a little bit simpler and doesn't take as much space as writing out, drawing out the diagrams. So this is called the drop and switch method. So the first thing you do is you find the ionic charge of both elements. So let's say we're going to do beryllium and nitrogen. With my periodic table, I can figure out beryllium's +2 and nitrogen is -3. The charge of the atom becomes the number of other atoms. So you ignore the sign. So in this case, beryllium is 2 and nitrogen, the charge is -3. So we're going to use the 3. And the reason this is called drop and switch is because you drop the number to the bottom and switch it to the other element. So the 2 from the beryllium charge goes after nitrogen, and the 3 from the nitrogen charge goes after beryllium. If you can reduce it, reduce it. This one cannot be reduced. So our final answer is Be3 and 2. All right, we then practiced writing ionic formulas, so you can work through these if you'd like. And then we talked about naming. So when you're naming, you say the first element and you replace the second one with ide, I-D-E. So for example, here we have lithium and chlorine combined to make lithium chloride. For calcium and oxygen, it makes calcium oxide. Aluminum and iodine make aluminum iodide. And then the last one is second to last is potassium nitride, and last one is strontium phosphide. We then practice naming by naming these: magnesium nitride, rubidium nitride, strontium fluoride, aluminum oxide, and magnesium sulfide. We also talked about naming transition metals because they sometimes need a Roman numeral because they can have multiple charges. So the way you indicate the charge on your transition metal is with a Roman numeral. So copper 2 ion ends up being copper, parentheses, 2 in Roman numerals. So the way you figure out the charge on a transition metal is you look at the anion it is bonded to, and you know the two of them have to make a neutral charge. So sulfur has a -2 charge, so copper's got to have a +2, so the overall molecule is neutral. That makes this compound copper 2 sulfide. They work through another example down here. We know each oxygen has a -2 charge, and you have 3 oxygens, so the charge from oxygen overall is -6. So our 2 copper ions need to have a combined charge of +6, meaning each one has a charge of 3. That makes this copper 3 oxide. So we practice naming them. This first one is titanium 4 sulfide, because each sulfide is 2 minus or -2. This one is cobalt 2 chloride. This would be tin 2 phosphide, and this would be chromium 3 bromide. We also practice going the other direction. So magnesium oxide, well, magnesium is +2, and iodide is -1. Just pretend like that's a 1. So, well, this one doesn't, yeah, and this one doesn't need anything. So magnesium, iodide, and then we have to drop the 2. Mercury 1 sulfide, so that would be Hg +1. Sulfide, sulfur has a -2, which means we would have to drop and switch and put a 2 here. Strontium oxide, Sr is 2 positive, and the ones without the Roman numerals are because they're not transition metals. So strontium is 2, oxygen is also 2, so we can reduce this. So all we have to do is write it together. Strontium oxide. Titanium 4 nitride, so titanium is Ti, that has a 4, and then oxide is oxygen. Oxygen is 2 minus, so 2 on titanium, 4 on the oxygen, but we can reduce that by dividing everyone by 2, so it's going to be TiO2. And then calcium chloride, so calcium is 2 plus, chlorine is -1, so the 2 comes down here, and you write it CaCl2. So on Monday, we're going to be doing an assignment just like that, where you practice naming and writing the molecular formula. And next week, at the end of the week, so probably Wednesday through Friday, I'll try to have it open. There's going to be a quiz on ionic bonding, properties, and naming. If you have any questions, please come to office hours. Bye.